All right. So for this e-learning day today, we're going to be talking about net force. So we've used the term net force, like when we were talking about Newton's first law. We said an object in motion stays in motion unless acted on by net force, or an object at rest stays at rest unless acted on by net force. But what is a net force? So I'm going to give you a couple definitions. I'm going to give you what I think is the most technical definition, and then I'm going to give you a definition that I think is easier to think about. So the most technical definition of net force is that it's the vector sum of all the forces acting on an object. So I add them all together. Maybe the easiest way, though, to think about it, what I will often use is, I'm putting it in scare quotes because it's not a very technical definition, but it's a helpful definition, which is who's winning and by how much. And I'll show you what I mean by that here in a second. So that's your definition of net force. So we're going to do a few examples to get an idea. I think the easiest way to learn about net force is doing examples. So example number one, imagine you got this problem and it said that you had a ball that's falling through the air. So that's my ball that's falling, but we're going to say that this ball is not technically in free fall because there's some air resistance. So we're going to say that gravity is pulling this ball down with a force of 200 newtons, but there's some air resistance on this ball and it's pushing it up with 75 newtons. And let's say that the question was, find the net force. Well, so vector sum of all the forces, what that means is basically what's one vector that summarizes both of those forces. But using my definition, who's winning and by how much? Let's think about this. Pardon me, well, who's winning? It looks to me like the downward force is winning. So I'm going to draw my net force vector pointing down. I always draw net force with a double arrow to separate it from regular forces, which are single arrows. So this is the net force vector. And how big is it? Well, it's who's winning and how much by how much. So down is winning, but how much is it winning by? It's probably winning by 200 minus 75. So I would say that my net force is 125 newtons. Now, net force is a vector, and remember vectors have two things. They have magnitude and direction. I have indicated my magnitude. It's 125 newtons big, but what's its direction? Down. So that would be an answer for the net force. 125 newtons down. So that's an example. Let's try another one. Let's imagine that we've got a book here sitting on a table. So there's my table. Here's my book sitting on the table. Well, this book isn't flying. Why isn't the book flying? Because it's got some gravity, and I'm going to say that there are 20 newtons of gravity. I don't know if I mentioned, but when I say 20 newtons, newtons is the unit that we're going to use for force. So we've got 20 newtons of gravity pushing the book down. But why isn't the book falling? Well, it's sitting on a table, and so the table is pushing that book up with the same amount of force, 20 newtons. So what is the net force in this case? Well, who's winning and by how much? It's a tie, which means that the net force is probably 20 newtons minus 20 newtons. The net force is 0. Whenever the net force is 0, you don't need a direction because 0 doesn't have a direction. 0 is just 0. All right, one more that's just a little bit, that just adds this to the next level. So imagine a car zooming down the interstate. So there's my car zooming down the interstate, and we're going to say that it's accelerating down the interstate. So here's my car accelerating down the interstate, and the problem would say, well, this car has a weight or a force of gravity of, let's say, 3,000 newtons. But this car is not going down, right? So the road has to be pushing it back up with that same force of 3,000 newtons. And then I'm going to say that the engine is pushing this car forward with a force of, let's say, 6,000 newtons. And there's some friction acting on the car going backwards, and I'm going to say that that is 4,000 newtons. And the question is, what's the net force? Well, the only thing that makes this one here a little bit different is that I now have X forces and I have Y forces. So we have to treat this separately. Now you'll get to the point where you can do some of this in your head, but I'm gonna write it out explicitly. So we've got two calculations we got to do. We got to find the net force in the X direction. So I'm gonna call that F net X. And in the X direction, who's winning? Forward. By how much? Well, 6,000 minus 4,000 is 2,000 newtons. So that's going to be the net force in the X direction. And then we also have to do this in the Y direction. And we're going to say that the net force in the Y direction you'll probably see is going to be 3,000 up minus 3,000 down. So the net force is 0 newtons in the Y direction. So what does that mean? Overall, what's the net force? Well, overall, the net force is not pointing in the Y direction. It's only pointing in the X direction. So it's the forward force it's winning. So we're going to say the net force is 2,000 newtons in the forward direction. Or you could say right. 2,000 newtons forward. That would be an answer there. That's the basic idea about net force. From here, you can probably, from here, this is how to calculate the net force if you are given all the forces. If you are comfortable with this, you can go ahead and take the Check for Understanding quiz. If you're not comfortable with this, I'm going to post one more video that talks about what if I give you the net force and I'm asking you to find one of these other forces. And so you may watch that, especially if you get to the Check for Understanding quiz and aren't quite sure what to do.